Hi, welcome to Mathviz. Once again, I am here with very important topic for you. The topic is upper bounds and lower bounds. This is IGCSE Maths topic, and every time question is asked in the exam. So first of all, in this video, we'll be seeing rules to find lower bound and upper bound, and then we'll solve some problems based on that. And we'll see how to use these rules, and that makes very easy to solve the problems like this. Okay, so let's start with the rules. So if a number n is correct to the nearest unit can be a millimeter, centimeter, meter, kilometer, whatever unit, or a whole number. In that case, we'll take 1 divided by 2. So 1 divided by 2 gives us 0.5. That means we need to subtract 0.5 from the given number to find the lower bound, and to find the upper bound we will add 0.5. This is the rule. So n minus 0.5 gives us lower bound and n plus 0.5 gives us upper bound. Now next one, to the nearest 10. So to the nearest tens we will take 10 divided by 2. So 10 divided by 2 is 5. So subtract 5 from the number to find the lower bound and add 5 to the number to find the upper bound. So n minus 5 and n plus 5. N minus 5 is the lower bound and n plus 5 will be giving us the upper bound. To the nearest 100. So 100 involved here. So 100 divided by 2. So 50. Now sub n minus 50 gives us lower bound and n plus 50 will give us upper bound. This rule, I am talking about this rule. Now to the nearest 1000, then what will do? Take 1000 divided by 2, 500 will get, then subtract 500 from n and add 500 to n. If your n minus 500 gives us lower bound and n plus 500 gives us upper bound. Now if it says to the nearest 10,000, so we will take 10,000 divide by 2, so we will get 5,000. That means we need to subtract 5,000 from the number and add 5,000 to the number. N minus 5,000 gives us lower bound and n plus 5,000 gives us upper bound. So when you are adding, we get upper bound. When you subtract, we get lower bound. And what to add and subtract, that we are able to find from the question itself. In question it will be given always, it is correct to the nearest unit, to the nearest 10, to the nearest 100 or to the nearest 1000, whatever. Nearest lakh. If it is nearest lakh, we will take 1 lakh divided by 2. So need to add and subtract 50,000. Okay. Okay. If these were about the whole numbers, what if the number is a decimal number? So rules for decimal number also here. If a decimal number is correct to the nearest tenth or 1 dp. So 1 dp means you have to take 0.1 divided by 2. So 0.1 divided by 2 gives us 0.05. So we got the number. What you need to subtract or add? So to find the lower bound, we will subtract 0.05 from n, and to find the upper bound, we will add 0.05 to the n. Okay. Same way, if nearest hundredths or 2 dp, so we will take 0.01 divided by 2, that is 0.005. So we need to subtract 0.005 and add 0.005, and we will get upper bound and lower bound. To the nearest thousandths or 3 dp, then 0.001 divided by 2, that gives us 0.005, 0.0005, then subtract 0.005 from n and add 0.0005 to n, and this gives us the upper bound. So these are the rules. Okay. Now we'll see how to apply these rules in the problems. So let me show you the first example here. The population P of Brunei in 2008 was 40,000, 400,000, correct to the nearest thousand. Complete the statement about the value of P. So we have to write, see, two blank spaces given. On the left side, we have to write the lower bound, and on the right side, we have to write the upper bound. Now, how to find the lower bound and upper bound for 400,000? What you need to do? We need, see, first of all, check correct to the nearest thousand. So we need to take 1000 divide by 2, we'll get 500. So what will be doing? 500 we have to subtract and 500 we have to add to the given number 400,000. Okay. So let us find the lower bound. Lower bound is equal to 400,000 minus 500, and that is equal to 399,500. Now if you have to find the upper bound, we will do 400,000 plus 500. So you will get 400,500. So these are the answers. We can write in the answer space. So 399. Remember, smaller number always on the left side and bigger number always on the right side, because left side is the place for lower bound and right side is the place for the upper bound. Okay. Don't write reverse. Okay. So we are done with this. Now let's take the next question. The distance of 150 kilometer is correct to the nearest 10 kilometer. See here, kilometer given 150 kilometer, and this is correct to the nearest 10 kilometer. So what will be doing? Take 10 divide by 2. We get 5. So that means to find the lower bound, we will subtract 5, and to find the upper bound, we will add 5. Where? In 150. So lower bound 150 minus 5, that will be 145. Upper bound 150 plus 5, that is 155. So answer here. So you write here 145, 155. Okay. Now let's go to the next example. Ingrid throws a javelin a distance of 58.3 meters, correct to 1 decimal place. So be careful here. It says correct to 1 decimal place. If you remember the rule, it says correct to 1 decimal place means we will take 0.1 divided by 2. You can go up. Let us go and see here this rule, 1 decimal place. So this gives us to the nearest tenth or 1 dp. So 0.1 divided by 2, that is 0.05. Okay. So we need to add here, subtract 0.05. So 0.1 divided by 2, we get 0.05. Okay. Now to find the lower bound, we will be subtracting 0.05, right? So lower bound is equal to 58.3 minus 0.05, and that will be 58.25. and upper bound 58.3 plus 0.05, that is 58.35. So answer will be here 58.25 and 58.35. Done. Let's take the next example. A box is 12 centimeter high. Correct to the nearest centimeter. See, here it says 12 centimeter high and correct to the nearest centimeter. So correct to the nearest centimeter means correct to the nearest unit given here. So unit means 1. You will take 1 divided by 2, you will get 0.5. Okay. Now 0.5 we need to subtract and 0.5 we need to add. So lower bound equal to 12 minus 0.5, that will be 11.5, and upper bound is equal to 12 plus 0.5, that is 12.5. So answer you can write it here 11.5, 12.5. So H lies between 11.5 and 12.5. Okay. Okay. Now if calculation involved in the problems of involving upper bound, lower bound, if calculation involved, in that case also we have some rules that you need to remember how to apply the calculation rules. So let me show you here with some examples. So let A and B be two numbers. Okay. So a lower bound of A will be on the left side, upper bound of the A will be on the right side. Same way for the B. Okay. Now let us see rule number 1, addition rule. If addition involved, in that case, if you have to find lower bound of addition, lower bound of sum, then you'll be taking lower bound of the first number plus lower bound of the second number. Okay, if two numbers you have to add and we are finding lower bound, then find the lower bound of both the numbers and add together. To find the upper bound, we will take upper bound of both the numbers and add together. In this case, examples given here A and B. If A and B are two numbers, then lower bound of A plus lower bound of B gives us lower bound of A plus B. And upper bound of A plus upper bound of B gives us upper bound of A plus B. Okay. Now, if you have to find lower bound and upper bound for subtraction, difference, in that case, see the rule. Here rule is reversed. A lower bound of A minus upper bound of B. This gives us lower bound of difference A minus B. And if you have to find the upper bound, we have to be very careful in this rule. Upper bound, if you have to find, then upper bound of A minus lower bound of B. Now, rule number 3, multiplication rule. Lower bound of A into lower bound of B gives us lower bound of A into B, product. If you have a product, so to find the lower bound of product, we will find lower bound of first number into lower bound of the second number. Both lower bound will be combining and multiplying. Now, in case of upper bound, you have to find, then we will take both numbers upper bound and multiply together. Okay. So, if you see the rule for addition and multiplication, they are similar, same. And for subtraction and division, rule is same. See, if you have to find lower bound of division or quotient, in that case, lower bound of A divided by upper bound of B. So, one you are taking lower bound, so other you are taking upper bound. In case of division and subtraction both. When we will be seeing the examples, then it will be more clear to us. Okay. So let me show you some examples here. Carmen spends 5 minutes. Correct to the nearest minute. So 5 minutes given here. Correct to the nearest minute. Preparing one meal for one meal. So 5 minutes correct to the nearest minute, nearest unit given here. So 1 divided by 2, that will be 0.5. Okay. Now she spends a total time of T minutes preparing 30 meals. This time we have for one meal and she is preparing 30 meals. Between what limits does T lie? So you have to find what is the upper bound and lower bound for T. T is the time for 30 meals. Okay. So first of all, for 5 minutes we will find, see, we have to find lower bound and upper bound for 5 minutes. So lower bound will be given by 5 minus 0.5, that is 4.5. So this is for 1 mil. Now there are 30 such mils, so into 30. Then if you multiply, what will you get? 135. Okay. Upper bound 5 plus 0.5, that is 5.5, and again for 30 mils, so into 30, so it is 165. Okay, so here comes 135 and here goes 165. Done. Next, a rectangle has sides of length 6.1 centimeter and 8.1 centimeter. Correct to one decimal place. So correct to one decimal place means 0.1 divided by 2, that is 0.05. So this we need to add and subtract for finding lower bound and upper bound for the side lengths. In this case, we have to find the lower bound and upper bound both for the perimeter. Now you have to see in perimeter. So let us find first for 6.1. If you are finding lower bound, you here 6.1. If you are subtracting 0.05, you will be getting 6.05. So this will be your lower bound. 6.15 will be upper bound. Okay. Now for 8.1, let us find similarly. So it will be 8.05 and 8.15. Now we have to find perimeter lower bound and upper bound both. So in perimeter, if you write the formula, perimeter equal to 2 into L plus B, right? So here addition involved, right? So if you have to find lower bound, you will be taking lower bound of length and width. So that means 2. Here it is lower bound equal to 6.05 plus 8.05, and if you multiply out, that gives us 28.2. If you have to find perimeter upper bound, then 2 you will take both upper bound. I am talking about this 8.15, 6.15. So 6.15 plus 8.15, and if you multiply out with 2, that gives us 28.6. So you can write in the answer space 28.2 and 28.6 centimeter. So we are done with this question. I hope this is clear to you. Let's take another example. A rectangle has sides of length 2.4 centimeter and 6.4 centimeter. Correct to one decimal place. Correct to one decimal place again. That means you have to take 0.1 divided by 2, that is 0.05. We have to add or subtract. Okay. But this time question is asking calculate the upper bound. So in finding area, for the area, what we need to do? Length into width. So multiplication involves. And if you see the multiplication rule here, it says in multiplication rule to find the upper bound, we need to multiply upper bound of length into upper bound of width. So we'll take upper bound of both and multiply. So let us find upper bound for both 2.4 and 6.4. So 2.4 plus 0.05 is equal to 2.45, and we have 6.4 plus 0.05, that is 6.45. So area upper bound is equal to 6.45 into 2.45. We'll get 15.8025. 15.8025. This is exact decimal, so we need to write all the digits. So we'll write here 15.8025 centimeter square. So some of the what happens sometimes students when solving the problem like this, first they find the area and then they try to find upper bound or lower bound. We should not never do like that. First we need to find upper bound or lower bound, whatever is required for the length of the sides, and then we need to put in the formula for finding area or perimeter, whatever we require. Okay. Okay. Now next example. Violet and Wilfred recorded their times to run 200 meter correct to the nearest second. Now Violet took 36 seconds and Wilfred took 39 seconds. So here it says nearest second. So nearest second means 1 divided by 2, that is 0.5. Right? So for 36, let us find upper bound. So to find the upper bound, one second. Let me correct it. Let us find lower bound and upper bound for both. 36 minus 0.5, that is 35.5. That will be lower bound. Okay. And upper bound will be 36.5. Now for 39. So 38.5 and 39.5. In this case, see, what is the question asking? Upper bound of the difference between their times. So difference means subtraction involved. So upper bound. So to find the upper bound of difference, the rule says, look at this. Upper bound of A minus lower bound of B. That means first number you have to take upper bound, and the second number which is being subtracted you have to take the lower bound, because that will be giving us the largest difference, right? See, you can see the numbers here. If you take 39.5 from here, this is the upper bound and this is the lower bound. Okay. If you are taking 36.5 here, upper bound in this case, that will be only difference will be 3. But when you are finding 39.5 and 35.5 difference will be 4. So that is the upper bound. So in this case, we'll be writing difference is equal to 39.5 minus 35.5, that is 4. So answer is 4. So this was the last example. I hope you enjoyed the video and you understood this topic. If you like the video, please subscribe the channel, like and share the video. Thank you. Keep watching.